we know that a bit string is the number of binary, is a string, like a string of binary digits that is made of zeros and one. And you know your zero represent, your zeros and one will represent your string, and your ones will represent the weight of that string. For example, if we want to calculate the number of bit string, you say find, okay, I'm just taking this from the quiz, find the number of bit strings that can be formed maybe the one that has the length, width length of 5, width length of 5 and weight of 3. Yeah, something like that. So this one is just find the number of bit strings that can be formed. Remember, bit string is just a string that is made of binary digit, either 0 or 1. Then that will form the length of the string. So the length will either be formed by zeros and one. For example, I think they gave an example on the textbook to say, okay, if we are looking at this, this is also a bit string because it is made of binary digits, 0 or 1. And one can say, okay, the length here is 3 because you have 3 binary digits. Remember, bit string is made up of binary digits where the number of those binary digits represent the length. So because there are 3 of them, the length is 3. The weight represents your ones. So it's 2 of them. So we can represent this symbolically by saying B32. 3 representing your length and 2 representing your weight of the string. Weight represents the number of ones, and length is just the number of digits, or the number of those binary digits. So in this case, with the length of 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's counting. So in counting, we only care about the number of choices that we have in each particular position. So it has a length of 5, meaning that it is made up of 5 binary digits. But you know that we have only 2 choices. It's either here they can be a 0 or they can be a 1. Because we want to count how many of those can we form. In counting, we care about the number of choices that we have in each particular position. So obviously it can be 0, 1, 0, 1, 0, 1, 0, 1. They never told us about the weight. So they just say find the length that has a length of 5. So we know we have 2 choices, 2 choices, 2 choices, 2 choices, 2 choices. We can either put 0, we can either put 1. So you have 2 choices, 2 choices, 2 choices. Then just be 2 exponent 5 and gives you the length of those things. I think also in the textbook they say something about you choosing yes or no. Can I put 1 here? Can I put 0? So those choices. So it's two choices. But then with the length of 5 and the weight of 3, it's different. That's where it starts to become quite challenging. We need to use combination, because remember, combination, it enables us to count the number of different combinations that can be made. That is, in how many different ways can you select something other than arranging something, as in like that would be permutation. If we are arranging people in a row, the number of different arrangement that you can put will represent your permutation, because order there matters. when you arrange people. For example, if you have A, the person A and B, this is the first arrangement. If I change the order, I change the arrangement, their arrangements in a way. So in total, we just have two arrangements that can be made, and that order then matters. So that will be your permutation. But in selecting something, if you are selecting something, the order does not matter because you are just selecting. You're saying, okay, this is a group of 5 students. I'm just gonna randomly select. So the order does not matter. So it introduces combination. So even and that's the fair way. You must not know what you're gonna select. If I know I'm going to a class, I need maybe a group of from 30, class of 30, and I need to select 5 people. Then for fairness, that must be done randomly. So you just go, okay, in the class of 30, you just start picking maybe people randomly. That will be fair, and the order won't matter. Your order of who you start selecting does not change your number of arrangement. But however, in permutation, when you change the arrangement, the seating arrangement, as an example, you change the what's that thing? You change your number of arrangements. I mean, you change your number of combination in a way that you can have. So this one with the length of 5, a weight of 3, I'm sure we are used to this. So it will be the length of 5 and a weight of 3. It means that we must have, if we are to represent this in symbols, which say, okay, because the weight must be 3, weight represent the number of ones that we have. That will be our weight. So we must have 3 ones. And obviously the rest will represent the zeros because we said a weight of 3. So 1, 2, 3 ones and 2 zeros like that. Then this is just the first arrangement that you can make. You can have a lot of different ways in which you can put that. You can start with this, like that. You can see that is the second way in which you can your bit strings can be formed. Remember, they want how many bit strings of length of 5 and a weight of 3 can be formed. So we can continue shifting this and putting it in this way, another arrangement like that. But it can take us a lot of time to actually find that. So counting help us to really count those in a fastest way. So we can just, okay, the length of 5 from 5 of my binary digits, I'm just gonna choose 3 ones. So in a way, it's combination because you're just gonna select 3 ones from 5 of them and you arrange them different. So this will give you how many different combinations of the 3 ones that can be selected and arranged and swapped and all that from a binary digit of, from a bit string of 5. So that will be 5, choose 3. And we can just punch it on the calculator. Just say 5, choose. There's an option for choose on the division. Then you can just click that. It is a C. So this C can appear on your calculator. You just press 5, then you press Shift, and you press divide. It will show you C in your calculator. So you press 5, Shift, and you press the division sign. It brings you a C, and you press 3. And it will give you the answer of 5, choose 3, which is 10. So it's only 10 of those bit strings that can be formed with the length of 5, weight of 3. Yeah, I think that's what I understand about the bit string and stuff. anyone who has a different explanation, or maybe the way they understand bit string? Yeah, Moponyo. Lawrence, you can just unmute. You don't need to raise the hand.
Oh yeah, I wanna ask, if there's I think I have a difficulties when we have a restriction. They tell you that maybe we either start with 101. Maybe they give you how many, they give you number of bit strings. They say maybe we have this number of bit strings, né? And then they're gonna restrict you to say we either start with 101 and then maybe end with 11. I think I have a difficulty with those kind of questions. If maybe possible, we can look at in the textbook,
quiz.
or even in the textbook.
Yeah.
There's a question on the exercises 1.2, number 4.
Okay, let me just, I think I'd open the textbook here, copy and paste it quickly. You say exercise is page what? It's under what?
It's page 79.
Okay. I'm opening the online one, so I'm not sure it's under what is the main topic? Is it
it's binomial coefficients?
Then it's exercise.
Yeah, it's the exercise at the end of 1.2, but at the end of binomial coefficients.
Which one actually? Exactly.
Page 79.
No, I remember the online textbook doesn't show the page. So the number of
the question, Mr. Mapon.
Was it number 4C?
Yeah.
Okay.
Okay, maybe I can read out the question.
Okay, I got it. I'm just gonna paste it quickly.
Okay.
Yeah, you can just is it? Is it? Yeah, you can just read out the question, Lerato.
Okay. Should I start from the statement? Okay, how many 9-bit strings? There is bit strings of length 9 are there, which, okay, so our focus will be on the last number C and D. So
C and D.
Yeah, because I think that's what Lawrence asked. It's either we start with a 101 or end with a 11. Then number D says we have a weight of 5 and either start with a 101 or end with a 11 or both.
Okay, just copy that also. Then Maponya, maybe you can first explain how you find the answer for A and B quickly. Then someone can also come in and just say what they think how they think we can solve it. Your C and D with A and B.
Number A idea is similar to what you just did now to say we're having how many bit strings? We're having a length of 9. So we're already given the first 3. Yeah, then we're only left with how many? 6. I think we're left with 6 from those. And it's either we choose 1 or 0. So it's 2. It will be 2 multiplied by 2 multiplied by 2. Basically 2 to the power of 6, I think.
2 to the exponent 6.
Yeah.
Yeah,
And
because okay, yeah. B,
B, I have weight of 5 and start with the sub 101. Here I'm saying I already have, okay, here again I already have the first 3, then I'm left with the 6. And then out of the 6, because they're saying my weight have to be 5, it means now I already have two ones there. So it means I'm only left with out of the other 6, I have 3 ones. Then I said 6, choose 3.
six, choose 3 as the answer of this.
Yeah.
Mm. Then it's number C, right?
Yeah.
Can we use this thing? Principle of inclusion and exclusion.
Yes, we can.
Can someone just explain it? How can we solve it?
We can, okay, either start with a 101 or end with 11. So we are already given that we have a bit string of length 9. So we're gonna put 9 spaces, and then we put we start with a 101, and then we have another 9 spaces and end with a 11. Then we're gonna add because we have a O there. But then, so since we have 2 traces, it's either a 0 or a 1. So we're gonna have 2 exponent 6. Not like this. We have the
First one. Oh, okay.
then another, yeah, like this, and then we have the other one. Then since there's an or in between, we have to add the 2 answers. But then we have, how many spaces left for the first one is 6 spaces. So we're gonna have 2 exponent 6 plus 2 exponent 7.
2 exponent 7.
Yeah, so we're gonna add both.
Then
Yeah, that's it. Since we are looking for where it either start with a 101 or end with a 11. Is there a both?
yeah, there's a
Yeah,
both
there's
there.
a both. So you have to minus the.
Or we have to subtract where we have both of them in the same length of 9-bit strings. So it's going to be 2 exponent. Yeah, 4.
It's giving us 176. Is it similar to what they got, Maponi?
Yeah, it's similar.
Yeah, I think it's just the principle of inclusion and exclusion. Was this thing there on the quiz? I think I saw something like this on one of the quiz. It's string.
Yeah. I think
But
last
was the answer correct?
Thursday.
No, remember we sent an email to him to say there was no correct option there. I think we were getting 160, and I think the lecture got something else. Which quiz was it?
Monday. Last week, Monday.
Yeah.
Yes. Yeah, I think so.
Yeah, I think
Right.
we got something different. It was quite a similar question.
Yeah,
Let
no, it
me
makes
try to
sense.
find
Yeah.
it. Sure. Okay, here's the question. Yeah, the number of bit strings of length 8 that will either start with a 1 bit or end with 2 bits of with a 1 bit or end with 2 bits of 00 shall be. So someone please can you try to just do that quickly and just we can just pass from these things.
Okay, we will have 2 exponent 7 plus 2 exponent 6.
I agree.
Minus
Nothing.
Nothing, because are we including both of them?
Minus 0.
but this is the principle, isn't it? This the principle of inclusion and exclusion. To
Yeah.
say if we want the cardinality of A or the cardinality of B is the same as cardinality of A plus cardinality of B minus cardinality of A and B.
Yeah, but there is no. Can I say there is no
No.
intersection? There is no both.
There's no both. Ne?
Still
We are not
separate.
a statement.
But I want to argue that I think it must be like this because we are calculating
Yeah,
A or B.
it's supposed to be like that. Like you're supposed
Minus,
to use that phrase.
it's like said, see, when there is no intersection, there is no intersection.
Then it's 0 because we are not given that.
But we can't assume it's 0 because unless if you prove for me that A and B, I wrote this even incorrectly. A and B is equals to 0 in this question, then you can argue that you have to put 0 here because you are saying this is 0. And someone can argue that no, it's not 0. What if I start with 1? There must be 8, 1, 2, 3, 4, 5, 6, 7, 8. Then I end with your 2 zeros. Are you saying the answer of this, which is 2 exponent 1, 2, 3, 4, 5, is 0?
Okay, what does or insinuate, Mr. Ndo? Or how are the events? Or
No, in this question specifically, we can say that the intersection is 0 because the statement didn't touch at the both sides of the two. We can say 2 events, but then now if we are given that, we should also consider where we consider both of the events. Then that's when we're gonna include the inclusion. That's how I took this question.
and I agree with you.
I'm still disagreeing. I think it's the principle of inclusion and exclusion. Every time if we are calculating, if we want to find the cardinality of A or B, which is similar to what this question wants, they want either start with 1 bit or 2 bits. I think we need to use the principle of inclusion and exclusion. You can't say you're gonna add these, and remember, if you are arguing that because they didn't put the word or both, then you are assuming this is 0. Can we prove mathematically that if we include the word or both, this will be 0? If it's still 0, we can agree to put 0 there. But however, if we do both, there's an answer we are getting to exponent 4.
Mara,
And
no is asking for both.
it's asking for A or B, right?
Yeah.
And the formula says A plus B minus A intersection B. Whether they say both or
Oh,
this is
no,
the formula.
I get where you're coming from.
Or is there anyone with a different perspective from that?
No, I get where you are coming from.
Okay. I think we are already beyond timing. We're supposed to end at 10. Okay, we'll just end at 12:30. It's fine. Can we move from that is bit string and